Hi everyone. Today we shall discuss the control system subject module 2. In that first unit, block diagram fundamentals. Okay. So first we shall know block diagram. It is a shorthand pictorial representation of the cause and effect relationship between input and output of a physical system. So the main thing here is input and the output. Block diagram is a pictorial representation. Next, output. The value of the input is multiplied to the value of a block gain to get the output. So for y of s, what we will write? Vs into x of s. So this is the block gain and this is the input. Okay. So we will, the value of the input is multiplied to the value of block gain to get the output. So y of s is equals to 3s into x of s. Next, summing point. So here two or more signals can be added, subtracted at summing point. You can observe here output equals to what we can write? X plus y minus z. So this is also incoming x plus y minus z because here minus is there. Next, takeoff point. The output signal can be applied to two or more points from a takeoff point. So this is the takeoff points. Next, forward path. The direction of flow of signal is from input to output. That is the forward path. You can observe this is a forward path. This, okay. And this is a feedback path. From output to, it is going to the input side. From output to input. So this is a feedback path. The feedback path, the direction of flow of signal from output to input. That is a feedback path. Rules for block diagram reduction. Okay. So now we shall know the rules. Block diagram reduction techniques. First rule is, so for blocks in cascade, gain of blocks connected in cascade gets multiplied with each other. So G1, G2, it is like this. So what you'll write final C of S. So C of S equals to, we can write G1, G2, R of S. Okay. So we can write, we can multiply G1 and G2 here. Okay. So R1 of S equals to, you'll get G1 into R of S. C of S equals to G2 into R1 of S. But what is the R1 of S here? G1 into R of S. So you'll get C of S equals to G1 into G2 into R of S. That is what we have written in the pictorial representation. That is block diagram representation. For example, like this. G1, G2, G3 is there. So we can write it as one block G1 into G2 into G3. If any takeoff point is there, okay, this is nothing but a takeoff point. So this is a takeoff point. Okay. Takeoff point, then we cannot consider these three are in series. Okay. So only these two are in series. So we can multiply G1 and G2. Okay. Later we should shift either we need to shift this takeoff point. Then only we can solve this one. Okay, this is wrong if we write. So G1, G2, and we need to write R1 of S and G3 of S. Next, for blocks in parallel, gain of blocks connected in parallel gets added algebraically. Okay. So G1, G2, G3. These three are in parallel. G1, G2, G3 are in parallel. So what you can write? G1 minus, because here minus is there. So G1 minus G2 plus is there here. So G1 minus G2 plus G3. This is what we can write here. R1 of S minus R2 of S plus R3 of S. But what is the value of R1 of S? G1 into R of S. R2 of S value is G2 into R of S. R3 of S value is G3 into R of S. Finally, we can write like this: C of S equals to G1 minus G2 plus G3 into R of S. Next, eliminate feedback loop. Okay. So this is the feedback loop. This is the feedback loop. So how we can eliminate? This is the formula. G divided by 1 plus or minus G of H. So here, if it is negative, then here you will get positive. Okay. If it is positive, then you need to take here negative. So for positive feedback, you will get negative, and for negative feedback, you will get positive. So now if it, for example, here summing point is negative. So here G divided by 1 plus G into H. If it is positive, so G divided by 1 minus G into H, like that. Next, this is, they have solved this for negative feedback. Okay, they have solved this formula for negative feedback, and this is, they have solved for the positive feedback formula. Next, associative law for summing points. The order of summing point can be changed if two or more summing points are in series. So now two summing points are there. Okay. So two summing points are there. So what you can change? The order of summing points can be changed if two or more summing points are in series. So X equals to R of S minus B1. Okay. C of S equals to what you will get? X minus B2. Okay. X minus B2. So C of S equals to R of S minus B1 minus B2, because X value is this one. Okay. This they have substituted here. So R of S minus B1 minus B2. That whether we can change it. So here R of S, so he minus B2, and here minus B1. So X is equal to what you will get now? R of S minus B2, and C of S is equal to what you should write? X minus B1. If you change also, you will get the same. Okay. So when you compare these two equations, both equations are similar. Okay. Both equations are similar. R of S minus B1 minus B2, R of S minus B2 minus B1, both are similar only. So when the two summing points are in series, we can change it. Okay. Next, shifting summing point before block. Okay. We need to shift the summing point before here. Okay. So what you need to multiply? You need to multiply 1 divided by G. Okay. So what the value here is there? For example, if any number 3. So 1 divided by 3 we need to consider here. Okay. So C of S equals to, for this equation, C of S equals to R of S into G. So R of S into G plus X. This is for this figure. Okay. And here, so C of S equals to, if we shift also, we need to get the same equation. So in order to get the same equation, what we need to multiply here? So C of R of S divided by G. Okay. So R of S divided by G again into G. Okay. Equals to, sorry, R of S. Here C of S equals to G. That is this G into what you will get, R of S plus X divided by G. Okay. So when you multiply G into R of S plus X. Okay. Similar. This equation and this equation both are similar. So whenever you shift the summing point behind or before the block, so you need to get the same equation. That only you need to multiply. So here we have taken 1 by G. This is before the block. Okay. For after the block, we will multiply G. Okay. For after the block, we will multiply G. And next, that is what? Shifting summing point after block, we will multiply the G. You can observe here. Okay. So here what you will get? R of S plus X into G. Okay. Now R of S into G again plus X into G. Okay. Same value you will get. R of S into G plus X into G. So if you compare these two equations, the representation is different, but the final answer what we get is same. Okay. The representation may be different, but the answer what we get at the output side is same. Next, shift a takeoff point before a block. So here, one thing you need to know that summing point, that is summing point before and takeoff point after is 1 by G. Okay. And summing point after and takeoff point before, that is takeoff point before block. Okay. So here G. So shifting summing point after the block, if you want to shift, or takeoff point before we want to shift, then we will take the G. Okay, we will multiply G. And shifting summing point before the block and takeoff point after the block, then we will multiply 1 by G. So you observe now, shift takeoff point before a block, that is this one. Okay, so it is a G. So they will take multiply G. Okay, so R of S into G, what you will get? R of S. So C of S is equal to G into R of S. At X you will get R of S into G. Same you should get here. So in order to get that, what they will multiply? G. So C of S equals to G into R of S. Okay. Here, and X is equal to what you will get? X is equal to, you will get the same. R of S into G. Okay. Next point, next rule is shift a takeoff point after block. So what I have written, shift a takeoff point after the block. So after the block, what I have written, 1 by G. Okay, so 1 by G. Next we shall go with the rules. Okay, before solving problems, some first choice what we should consider in the problems. Okay, so first preference is series. So whenever we solve the block diagram problems, first we should see that whether the blocks are in series. Okay, first we should see the whether the blocks are in series or not. Okay, first preference we should see that one. Next we should go with the parallel. Second preference is parallel, and third one is feedback loop. Okay, so second choice, equal preference, that is adjusting summing order, shifting summing point before or after block, and shifting takeoff point before or after block. These rules we should apply later. If okay, this is the second choice. After this is the first choice and this is the second choice. Now we shall solve the problem on this block diagram reduction technique. So by seeing this example, first we need to give a preference for series. So whether the blocks are in series, rule 1 cannot be used as there are no immediate series blocks. Next preference is parallel. So hence rule 2 can be applied to G4, G5, G5, and G4, G3, G5. So you observe this direction is same. Okay, G4, G3 and G5. So what we can write, parallel to get an equivalent of G3, G4, G5. This is the direction like this. Okay, it is bound, it is direction like this. Okay, so 3 blocks are in parallel. You need to add G4 plus G3 plus G5. Okay, make it one block. So these 3 blocks are in parallel. So apply rule 2. Blocks are in parallel. So what you'll get, G3 plus G4 plus G5. And next here, these two are in series. Okay, so multiply. What you'll get, G2 into G3 plus G4 plus G5. Okay, make it one block. Again, apply rule 3, elimination of feedback loop. This is the feedback loop. So what you can write, G1 divided by, whether it is positive or negative, it is negative. Okay, so this is a negative. So what you should write if it is negative, 1 plus G1 into H1. Okay, next after getting that, so we have solved these two. So now these two blocks are in series. So G1 into G2 into G3 plus G2 into G4 plus G2 into G5. That you write down. Okay, or you write down G1 into G2 and G3 plus G4 plus G5. Okay. Next, after solving this, 2 blocks are in series. Next, again you will get rule 3, elimination of feedback loop. So this is nothing but G, right? This is nothing but feedback path. So G1, G2, G3 plus G4 plus G5 divided by 1 plus again. Okay, so what you will get is G1, G2, you take it as Z. Okay, so if we take it as G, then G divided by 1 plus G into H2. Okay, so substitute the value of G, this one. Okay, when you substitute and take LCM, later you'll get this value G1, G2, G3 plus G4 plus G5. I will solve here. So G1, G2, G3 plus G4 plus G6, sorry, G5. Okay, so divided by 1 plus G1 into H1, 1 plus G1 into H1. Okay, again 1 plus, same you need to write here, again G1, G2, G3, G4 plus G5 into H2 divided by it is only divided for this. Okay, so 1 plus G1 H1. When you take LCM here, so what you'll get 1 plus G1 H1 plus this one. Okay, so this will be cancelled. So this way you'll get cancelled. So 1 will become 1 plus G1 H1 and this one answer you'll get. Okay. Next problem. Here, so these two blocks are in series. So G1 into G2. Okay, rule 1. Next, these two blocks are in parallel. G4 plus G3. Okay. Next, again these two will become, whether it will become series? No, because you need to solve the loop. Okay. So these two blocks are in series. You will get G1, G2 and these two blocks are in parallel. Okay. These two blocks are in parallel, which is marked in yellow color. So G4 plus G3 plus G4 and these will become minor loop. Okay, this is the minor loop. So G1 into G2 divided by 1 plus, because minus is there, 1 plus G1 G2 into H1. So this is the answer. Again these two blocks are in series. So multiply and again loop. So you'll get the answer final. Okay. In next class, we shall discuss with the signal flow graph. Okay. Or some more problems on block diagram reduction only. Subscribe channel for more updates.